Okay, I got here back in December of 1973 and drove in and met Jerry Cup in the parking lot about 5 o'clock in the afternoon coming from Washington State. And that was kind of my first view of Corkscrew. And basically Corkscrew is right about here. These are sort of the major physiographic regions in South Florida, the Everglades, Big Cypress Swamp, and Corkscrew Swamp. And Corkscrew is kind of an extension of Big Cypress Swamp that extends a little bit to the north into what's known as generally as the Western Sandy Flatlands. It occupies a lot of this area and kind of goes down along the coast, down in that area. Basically, I came here because on a subcontract from the University of Florida Center for Wetlands. And they had a study going looking at using cypress domes as tertiary treatment systems for domestic sewage. And they were dealing with ponded, relatively young systems, and what they were looking for as a control that they wouldn't be dumping any sewage into, but they could get a sense of how flowing water and old growth systems, cypress systems, compare to what they were studying up in northern Florida. And National Audubon Society was very concerned about the Golden Gate Estates that had just come in down a few years before, down to the south. And they wanted to try and understand what kinds of effects that the Golden Gate Estates were having on Corkscrew so that they could possibly take action in order to sort of avoid, restore, protect themselves from those kinds of effects. And the land managers had questions about just kind of the activities that they were doing on site, whether it had to do with burning or mowing or exotic control, whatever it was at that point in time. So those are kind of the audiences that this study was aimed at trying to provide information for. And one of the really nice things about it is we looked at, this is a suite of things that we looked at as part of this study at some level. Odom had something like a dozen PhD professors doing this work and probably about 20 graduate students contributing to this effort up in northern Florida. Down here, it was me, Ed, a fellow by the name of Rita Pell, my ex-wife, Linda Duever. That was the whole team that was trying to figure out how to cover those bases out there. And I've kind of highlighted a few things here in terms of that were particularly important and tied together. And one was hydrology. That it became very apparent when I started doing some literature search on this area back in the 70s that while there was all kinds of hydrological work going on in South Florida, and people were studying well fields and landfills and levees and impoundments, pump stations, well fields, all kinds of hydrology going on down here. But as far as I could find, there was something like 2 or 3 hydrological monitoring stations in South Florida, down in the south end of Everglades National Park at that point. And nobody else was studying places just out in the middle of natural areas. And part of the problem was they seemed like they either like to take a helicopter to get in there, or a car, or a boat, or an airboat, or something to get to the sites where they're monitoring. Whereas in order to get into these cypress swamps, we had to walk or canoe. And so I think that was part of the reason a lot of that very little information was available on these natural systems out there. So hydrology became a real big focus for trying to figure out how these systems work. And another thing I've highlighted is chemistry of these systems. We actually got chemistry on the water, rainfall, the soils, vegetation, litter, and all, trying to understand sort of nutrient budgets. And that was sort of tied into what Odom was doing with the secondary street sewage, because he was studying sort of nutrient budgets and chemistry of these systems as affected by putting sewage into it. And then there were a lot of other things we looked at to try, and we did a little bit with animals, mostly because Ed wanted to do something with animals. And so we did a little bit on that. But we did a lot on the vegetation. And we got into some we wanted to try and see how things change over time. So if the system exists now, how does it compare to what it was originally? Again, the question Audubon had, how is it changing as a result of kind of development around us, particularly Golden Gate Estates? And then also some things that are going on in the area were fire, logging, and cattle grazing. They had cattle on parts of the sanctuary back in the mid-70s or so. And there was a lot of question as to what kinds of effects that was having on the system. So basically, we addressed all of these things, and even in 40 minutes, I don't have time to really tell you more than just give you a list of what we did on this. What I'm trying to do is sort of hit some of the things that we did that we think were really important and show you some results of some of the research that was done here. So Corkscrew is right here. This is the top of the watershed for Corkscrew. And back in the 1970s, mid-1970s, this place had very, very little impact. I mean, it was mostly open range grazing around there. There wasn't a lot of ag. There was some. There were vegetables out there in places. But an awful lot of the area was just open range, relatively undisturbed. Golden Gate Estates was down here, and that's one of the things we were worried about being affected by. And so we just started monitoring all kinds of things, trying to say, okay, how has hydrology been affected? How have the plants been affected? We did photo points on pictures from the 50s that my boss, Sandy Sprunk, took, and trying to see, okay, how things are changing in that. And one of the interesting things about it was we couldn't find anything, at least back in the 70s, that indicated that this place had been significantly changed. And if that is the case, then some of the data that we collected here back in those times probably represented as good a data as exists on what South Florida was like before development occurred in the area. So, and that's kind of what I'm going to be showing you a lot of today. Okay, Corkscrew. We're right over in here now. This picture was taken in the mid-70s. That's the old visitor center was right here, the headquarters area. And essentially the major communities here was the big Horseshoe March out here, the cypress around it. The cypress divided into two kinds of cypress in a way, structurally anyway. You've got the big old growth trees along the central marsh, and then you've got these relatively young cypress around the side. And going up gradient into wet prairie and pine flatwoods. So we just, again, with a limited staffing in that, we couldn't break it into too many different plant communities, so those are the ones that we were basically working with. Pine flatwoods back in the 70s. This is a hardwood palm hammock up on the north end of the sanctuary at Grapefruit Island. This is the wet prairie along the original boardwalk out there. Basically, what we call a wet prairie is a mineral soil marsh. It's generally relatively short vegetation, very open vegetation, a lot of light getting into the water, so you're getting periphyte and algae, and a lot of support for a lot of the aquatic fauna that lives in this environment. A marsh out in the center, the central marsh, and Horseshoe March. And this is on about 6 feet of organic slopes. And it has a very, very different vegetation. It's much taller, it's much denser, and it's much less diverse. It's dominated probably by half a dozen species, as opposed to the wet prairie having potentially hundreds of species out in there. Small cypress, young cypress is what we call it. So that sort of on the edge there, dense, smaller trees. And then the old growth forest in the center, sort of much more widespread trees, much taller, much bigger trees, and a hardwood forest that is succeeded into that area. And then there are open water places. This is a pond up at the north end of the sanctuary, and the lettuce lakes would fall in this category. Okay, the purpose of what we're trying to do there is to try and understand natural processes out in the area here. So even if this place wasn't functioning naturally, we wanted to try and figure out what they were before so we could return it to that. So that was sort of our starting point on it. And we wanted to document responsive wetlands to human actions, or be able to, with the idea in mind that if the managers do something here, what are the long-term implications of doing that? Not just the short-term implications. You go in and you burn or something like that, and how often should you burn? And if you're not burning enough, what's the implication of that? And also unintended complications. associated with development off-site, what ag is doing around here, what nurseries might be doing, what residents with the community out here might be doing in the area. Just so that the managers would have a better sense of just how to protect themselves from it as much as possible and minimize whatever impacts there are on that. Okay, this is essentially the major habitats and some monitoring transects at Corkscrew Swamp that we put in back in 1974. There are 4 transects, and essentially the flow through the system is like this, coming in from the east and going out mostly to the south. And so we were trying to get sort of sample the water as it's coming into the system, going through marsh system, going through cypress system, and going out of the south, out of the sanctuary. So again, these are the different communities that we're dealing with, scattered across the landscape. Most of the uplands are pinelands, and the hardwood forests typically are relatively small islands out in that upland pine landscape. This is what we call the Central Marsh Transect, and essentially it's this transect right here. That's where we did an awful lot of our work, because that's where the old growth cypress were, and that's one of the things we really wanted to try and get a better idea of. And so we went in, and it took us about 6 weeks to essentially clear a transect across here that, thank God, to the advice of one of the locals that told us, he was the one putting in these wells that we've got out there. You really ought to put a canoe trail in here. Because we were there during the dry season. We had not seen a wet season yet, and he was right. It really paid off, even though it took us. And we did. All we cut were logs, knees, and I think the biggest tree we cut was about that big around, and we put a canoe trail through there, which is one of the reasons that it's not a straight line. The other reason is that the wood sturks were nesting out here when we got to about this point, so we had to go around where they were nesting there. So this is the transect. It shows our vegetation plots and the different habitats, and the pine and the hammock, the wet prairie, the small cypress, the big cypress, and out in the Central Marsh. And it also shows locations of wells that we put in, shallow wells that we put out there in order to try and document the hydrology of the area by habitat. One of the things, too, with that transect was that we surveyed along the transect. Every 25 feet along the transect, we got an elevation. And because we wanted to be able to extrapolate to, say, the whole area of pond cypress or small cypress from the well that was in the small cypress. So that way we can get a lot more data points and get a lot better estimate of what the hydrology is, what the ground surface is, what the water depths are in each of those areas. So that was very helpful. And also we had to do survey in our wells also, so we could build profiles of the water table out there. So this is that last figure I just showed you up here, and this shows kind of the elevations that we surveyed every 25 feet along that transect. Essentially, all these points drop down from up here. These points up here are every 100 feet. But we surveyed every 25 feet and dropped those points down on these lines. So this is like a lettuce lake here, this depression here, this is a hardwood hammock at this site. This is the Central Marsh, which is kind of interesting because it's higher than the cypress is on either side out there. So that's kind of some of the information we were generating. As I said, actually, one of our mottos when we were working out here is, if you can't do it with a machete, forget it. And this is kind of macheteing in a well out there. And essentially, you just sit there and bang on it and drive it in, and then it's open at the bottom and flush it out after you get it down to the depth that you want it. It's open at the end. And they work great. This is a local guy, Buddy Hester, who lived down the road here, and we hired him to put the wells in. And did a great job of it, really. Let's see, yeah, basically they're hand-driven. We've got, there's about, half a dozen or so plant communities. We have 31 wells in altogether out there. So we had multiple representation of the various habitats. We tried to get the representation over as much of the sanctuary as we could, too. So they weren't all clustered around in the same place. And in addition to having the 31 wells that we measured by hand, we had one water level recorder and one recording rain gauge at each transect, which obtained continuous records of rainfall and water levels for the transect. And again, allowed us to extrapolate our weekly readings to information on sort of what's happening continuously through the whole week. So, what does hydrology do? Hydrology directly influences species composition and distribution of wetland communities. If it's deep, a lot of plants can't handle it. If it's not deep, aquatic fauna can't handle it. So it directly affects the kinds of things that are there, where they occur out there. But the other thing is it also indirectly influences these organisms, and by fire regimes. I mean, obviously, water levels have a big effect on what kind of fires you get, where they occur, how severe they are. So that's important. And also substrate characteristics. The reason organic soils exist is because essentially it's anaerobic most of the time, which means they're inundated for most of the year. Particularly during the summer months when it's warm and they tend to decompose fairly rapidly. And that's our wet season, so water levels are high then, and the organic soils are protected at those points. However, if you pull the water table down, they go away real fast. That's going to be a big problem. Got carried away. Okay, the first year we were there, we had about 6 months data or so by the time the first annual report was due. And this is essentially the water levels, the range of water levels in the uplands, marsh communities, and cypress that existed at those 31 wells. So during the wet season, they're fairly tight. The upland is actually has the shallowest water levels all year round. And marshes are shallower during the wet season than cypress are. But you get down here in the dry season and you see a lot of overlap in there. And this is sort of another way of looking at some of the data. Essentially, the side here, going from 0 to about 300 days. And this is maximum water depth during the summer. So we're talking about like 25 inches over here. And these are pinelands, these are hardwood hammocks, these are wet prairies, marshes, cypress, and sort of one of those ponds. And there's a few outliers here that don't seem to fit. But those are sites that are along the South Dike. Essentially, there's a dike that's put along the south end of the sanctuary to try and minimize the effects of Golden Gate Estates. And so it's actually impounding water this is sort of what we call the mid-above site here. It's a marsh site, and it's considerably higher than the sites that are not associated with a levee. And so and this is mid-below, and it's in this case, it's in the range. But you see the same thing with the cypress. They're kind of out of the range as a result of being above or below the dike. But other than that, we thought it was absolutely amazing that these things fit as tightly as they did, rather than being scattered all over the place. And so again, it was one of the arguments for saying that this area really hasn't been affected and it's still functioning. Hydrology is still associated with the kinds of plant communities that have been there for a long, long time. This is the same information, hydro period and minimum water levels down here, going down to about 50. Going down to about 70. So down at this end are the upland sites, and so it goes down lower in those areas. But one of the interesting things was this spread. It's not as tight as the upland, as the maximum water levels were during the wet season. And we were trying to figure out, okay, why are we seeing that kind of a pattern? And one of the things that sorted out very neatly on that was, these are about 8 or 9 marsh sites, marsh well sites that we had. And if you look at the pattern, this is kind of what we saw in that first 6 months graph I showed you, but this is going into the next dry season. And basically what you're seeing is that the surface peak depth is 0 or less at these locations. The water table goes down further. The surface peak depth is 0.3 to 1 meter at these locations. That's this group. in here, and it's more than 1 meter at well locations, and that's this group up here. It's the capillarity associated with organic soils. When they're in contact with the water table, it essentially raises the water table in the area. And so this really explained very nicely why we saw that sort of greater scatter in the water levels in the different communities. And this is hydroperiod. Basically, again, your upland communities, a hammock community here, pine. Myrtle, this is actually wet prairie. We called it Myrtle Prairie back when we first got here because it was mostly myrtle out in that area. And then the marsh, the organic soil communities, willow, cypress, and slough. And so it goes from about 0 to 350 days here. So that's kind of the way they sort it out. Again, fairly nicely. There's always something, one that doesn't quite fit or something, but most of them actually were, again, very tightly clustered. So this gave us sort of the option of, or the opportunity to kind of put together a diagram like this, saying, okay, in terms of maximum water depths and hydroperiod, this is where the communities break out, and the hydroperiods they have, and the water depths they have. One of the things that's very important for a lot of people to understand is that, I mean, we're talking about inches that sorts out these communities. I once gave this talk out in southeastern Arizona in Chiricahua Mountains. And I mean, they sort out their communities on thousands of feet. And they thought it was interesting. So it isn't water level here, it isn't elevation, it's how long conditions are anaerobic in the soil that sorts things out. So you get down into the slough and it's wet too long for things to become established and survive in there. So, and this is just sort of, when we're working with models and that, we try and provide modelers with sort of information on what hydroperiods are, and they're exclusive. Obviously, there's a fair amount of overlap between any of these adjacent communities. But as far as sort of what the hydroperiods are for the different communities, what the average annual wet season water level is, what the average annual dry season is, which is the 1 and the 10-year drought. So just trying to provide the best information we've got on this. Okay, monitoring at Corkscrew. In 59, Sandy Sprunt installed 2 staff gauges. And one out at the boardwalk at the Lettuce Lake, and the other at the boardwalk just as you're going into the pond site. Going in the front way, basically. That is not the gauge that was here, but he put a rain gauge in too. And when people talk about monitoring and how complex it is and how expensive it is and how time-consuming it is, this involved walking out and reading those gauges once a day. And that was some of the most valuable data we had, because these things were out there for 7 years before Golden Gate canals came in. So we had at least some baseline that we could use. And so, and this stuff is just invaluable for the long term. The monitoring data becomes more valuable the longer it is that you accumulate it. And so this has been in since 1959. And this is some of the data from it. This basically showing you the Lettuce Lake's water depth. And there's a lot of variation. I mean, the water levels vary from ½ a foot up to almost 5 feet. This is Hurricane Donna, by the way, right here. And so up to almost 5 feet a lot of years. But some years it doesn't really go down. And other years it doesn't go up. So there's a lot of variability. And that variability is very important for creating the diversity that exists out in the landscape here. Because some things do well in drier years, some things do well in wetter years. You're not going to get cypress germination out here out in the cypress unless it goes dry. And unless it goes dry unless you have a substantial dry season. So it's very important to maintain this variability. Another thing we did along that transect that I showed you earlier was that this is sort of our survey line. We went in and we did auger holes. Basically what we tried to do was put auger holes in the middle of the different communities, and then if there was no difference between this one and this one, we didn't put another one in, but if there was a difference between this one and this one, then we put one in the middle, trying to essentially nail down a little bit more closely where the changes in the plant community are. And probably the most significant things here as far as the communities that affect the plant communities is the fact this is a big sandy area out here. This is that peat area that I was telling you about, 6 feet deep or so. But another thing that's really important on it is this shell bed, because this we found out is fairly continuous. It's fine, you can see it along the Central March Transect, you can see it down the South Dyke, and a geologist told me that some of the same material you see down in Orange Tree. Before it was Orange Tree, and it was just a rock pit. And so it looks like that's a fairly long connected deposit of one sort or another. So those are kind of some of the main features that are affecting the plant communities out there. I'll talk more about some of those as we go along. And this is sort of a diagram of it, sort of limestone down below everything, sand pretty much everywhere out there. As you get into wetter, lower areas, peat accumulates. And typically, except when depressions like this, it seems like the topography stays within about 2 feet, a range of about 2 feet out there. And the peat is kind of what creates the evenness. That if the peat wasn't there, you'd have a lot more relief in there because it'd be down here, the ground surface. Now these are these shell beds I was telling you about. So. Okay, one of the things that, I saw on this, you can sort of see this little rock sticking up out in the middle of the wetland. This is it in the flesh. This is a hammock, hardwood hammock that's up around Mud Lake, up in the northeast corner of the sanctuary. And it's just classic. It's probably, I don't know, 3-4 feet lower out in this pond than it is in that island. You go down about 6 inches and you're going to hit rock in there. And that's why you've got this area here. Succession going from pinelands to hardwoods can only occur in the absence of fire. And the thing that protects this is it's got wetland all around it. And so it's less likely for fire to get to it, less frequently, less severe. And so these are the sites that have places that you tend to see these islands of hardwood hammocks out there. Okay, another interesting topic, fire. This is back in the 1970s, and if anybody's spent any time out in the North Marsh, it looks different now than it did back then. And so this is one of our prescribed burns. This is Washout Road here that goes up to the tower, right along Little Corkscrew Island. This is the Central Marsh. This is 2 days after burn in the Central Marsh. This was an area that had a little bit of sawgrass in it, but it had a lot of pickleweeds, arrowhead, maiden cane, some ferns, and this sort of thing out there. This is it, out in the same burn where it was pretty much all sawgrass. You don't want to be out there on a burn. That thing burned really, really hot and fast. So, but this is 31 days after the burn. This is the Central March Transect, going right down there. So you see how many willows there are out there? This is the North Marsh. This is right just south of Eagle Island, looking west over across the North Marsh, just before you get to Eagle Island. And Jim Hansen took these pictures, and he took a picture before burn out there, took a picture 16 days after the burn, took a picture 4 months after the burn. This is a picture I took one night out my back door down the street here. Again, back in the 70s or so. It had been burning pretty good during the day, but it was still burning at night out there. And the next morning, I kind of went over there to see what had happened. And this is the pine flatwoods that was burning out there. You notice the cypress dome back here. And there's the cypress dome on the other side of it now. And fire's going all around the cypress dome. It's just sort of crept a little bit down into the wet prairie. And there's the cypress dome. You saw the flames going up in there. Nothing happened to this cypress dome. And I went in there and I probed the depths of organic soils in there. And there was about 5 feet of organic soils in there. Again, this concept of sort of connecting the water table to the organic soils. keeps the organic soils more moist, provides moisture for the trees, the plants that are growing in there, and their transpiration actually creates a more moist microclimate. And so these things are much more protected from fire, even a big hot fire that's coming through the area, as long as the hydrology hasn't been altered significantly on it. This is lettuce lake, and back in the 70s. And it goes dry, went dry. That was sort of a famous palm tree out on that island for a while. And I was out there, actually, within a week or two of arriving here, Jerry Cutlet at a Christmas party decided we ought to go out and sink tussocks. It was about 10 o'clock at night. It was cold. And so we were out there, and I was swimming. And there's about 5-6 feet of water out there at that time. So that's a lot of going from being flooded to being dry. And the reason these things exist, there's an ash layer in the bottom of these lettuce lakes. They were created by fire. And we carbon dated some of the organics that had accumulated on one of the lettuce lakes that was about 540 years ago or so. So apparently there was one hell of a drought, there was one hell of a fire, and coincidentally we haven't been able to find any cypress that are much more than 500 years old out there with the tree coring stuff we're doing. So it's very likely that Corkscrew might not have existed as a cypress strand 500-600 years ago because it had burned up. But in a lot of ways, that's not so bad. 500 or 600 years ago, there were probably 20 or 30 cypress strands down here. Fakahatchee was there, and it's come back over that kind of time period. So just trying to understand these processes as far as sort of not just what the changes are, but the rates that you see changes out here. And there's Ed, another lettuce lake. There's an old cypress stump that's got charcoal on it. So this is actually along the Substrate March Transect. One of the questions people asked us was, why do we see this structure, the cypress forest? Why do you see that dome structure in a strand, or why do you see it in a dome kind of thing? And so basically, we had our transect out there, and we went through and we sampled cypress trees about every 100 feet, or actually about every 25 feet going into the strand. And we aged them, and we got BBHs on them. Essentially what we did was we took, divided up into 4 quadrants and took the closest tree in each quadrant. In some cases there were only 3 trees. And so what this data is showing is what the oldest tree that we found of those 4, because you can always have younger trees in an area. And so we've got the age, we've got the DBH, we've surveyed the surface, we've probed it, we know what the organic soil depths are out in it. And we had wells in there, so we know what the wet season water levels are, we know what the dry season water levels are during four different years out there. Wet season water levels tend to be pretty much the same most times, most years, because it rains, it fills up, it starts raining heavier, it just spreads out. It doesn't go up, it just spreads out across the landscape. So this is kind of the information we developed on it. And we had trees that were probably up to about 400 years old there. And so organic soil is about 6 feet deep or so there. So what kind of relationship really makes sense? It looks like the DBH and the age tie together very well. And there also seems to be a sort of an inverse relationship between the amount of organic soil and the age and the size of the trees. And so with the coring, we had a 3-foot core that we used to get into the big trees out here. And it took, actually we could do about 3 a day, and we're in a lot better shape then than we are now. But this is the relationship between the age and the DBH of those trees. That's pretty good. This is the relationship between the peak depth and the DBH. That's amazing. Really. And even you get a little blip in it, and it kind of follows the blips. Again, it's this kind of thing where we've got a system, just everything we kind of look at, we don't see any significant alteration, which would be other than what would be associated with sort of ecological processes operating in the system. So what it looks like is, again, this thing I mentioned about that cypress dome over here that burned, that where you've got contact throughout the year with a water table. You've got a more moist organic soil mass, which tends to sort of protect this area from fire. As you go out to the edge, the organics get thinner and thinner, and so the odds of fire getting in or more severe fire getting in get more and more as you go out to the edge. And so you end up with trees that burn up, and then you get new trees coming into the area. So it seemed to fit fairly nicely. This is the west side of the horseshoe. We didn't put the level of effort into that we did. I sent Larry Riopel out to go through it to the other end or so. He used water levels after it was very stable for a while to measure essentially the ground surface out there. And then these are the deviations of trees as he encountered. And I mean, seeing something like this is just kind of amazing. So again, it seems to work over on the west side too. Again, the relationship between peak depth and organic. We also, so we got a nice pattern here. It makes sense, and kind of we know what's going on. So we cored and aged cypress trees, surveyed topography, and probe peak profile along a transect that we put in here in what we used to call Northern Swamp. I don't know if that's what it's still called or not, but essentially we went all the way across there and generated that information. And what we found was that there seemed to be very little relationship between DBH and peak depth out there. And so it's very erratic, but it's erratic over the same range across the whole area. So we looked at the age of the trees and the growth rates of the trees. And interestingly enough, the age of the trees was highest on the edges. And the growth was much, much more rapid in the center. And so the explanation there is that the place burned up at some point in the past. These organics that you got here aren't anywhere near as deep as they were along the Central March Transect. I mean, they're about 2 feet deep as opposed to 6 feet deep. So much more likely a fire to get in there. And so when you get to these trees, basically what you're getting into is an area where trees are rooted in mineral soil. The fire comes through. If the fire doesn't get to the roots, it may top kill them. It may damage the top, but it's not going to kill the plant. They'll resprout and take off again. And so, whereas in the center, it gets into that organic soils, it gets to the roots, it kills the trees, but it's great habitat when the water comes back. And so the trees germinate and take off and grow like crazy. It's better habitat there than it is out here for them. And probably the other thing that makes a ringer is that Kathy Yu up in near Gainesville studied a cypress dome where the trees were all the same age all the way across. And basically her explanation there was the whole thing was wiped off at one time, it all receded in at the same time. And because the ones in the center grow faster, because it's better conditions, it recreated the dome pattern. This is another thing that sort of complicates it a little bit more even. When we looked at our trees out there, what we found after looking at enough of them was that trees grow faster when they're younger. And so what we had a start of a growth rate decline. We've got a period in here that's marked at about 70 years or so, when you can have maximum or not. You might not have good years, but if you get a good year, you can get a lot of growth out there. But after about 70 years, roughly, it tends to fall off. And by the time you get to about 150 years, it doesn't matter how good a year it is. The trees are just going to keep chugging along and chugging along and chugging along. And so if they'll keep putting rings on, so they get bigger and bigger, but they'll do it very, very slowly. So we kind of found that pattern and just kind of nailed down sort of the start of the growth rate decline, the start of the stable growth period. And what we wanted to do, that question, why are the big trees out in the, or why do we see that dome-shaped pattern out there? And what we saw was that generally there was an increase in the growth rate of the cypress trees from the edge to the Central March. It wasn't much, and then going from 3 up to 5 or so. But interestingly enough, out at the edge, when the trees are not in the forest, they're growing out in the open, there, along the Central Marsh, or at the lettuce lake, they can grow over 7 millimeters a year. So you see sort of different conditions. There is sort of better conditions for growth as you go from the outside to the inside. But once you get past that to that maximum stable growth rate, it doesn't matter how good a year it is or what condition. It's just they chug along at about the same rate no matter what. So one of the products we wanted to get out of all this was we wanted to understand how things change and what kind of rates they change at over time. And so there's a fellow, Taylor Alexander, that really kind of came up with these transitions for over in South Florida. And so I just sort of sold a lot of his and adapted it to the big cypress area. But the thing that he didn't have in it, he didn't have anything about how fast things can change. And what we tried to do here is to say that if you don't burn a marsh, it's going to go to willow. And the transition from being mostly marsh to mostly willow can be fairly short if there's enough. This assumes that there's seed available. If seed or propagules are far away, it can take longer. But this is just an average. And then given enough time, maybe you get out 70, 80 years or so, you'll start seeing cypress can come in. And actually watching out in the Central Marsh here, you can see that. And eventually the hardwoods come in, next swamp forest, and given enough time, everything would turn to hardwood hammock. But all of South Florida is fire environment. So they never get a chance to get this far, except very, very locally in very local situations. And what we wanted to do was try and generate this information so that if a manager was out there and he was saying, okay, something's going to change my fire regime, something's going to change my hydrology, this is sort of a prediction of what's going to happen as a result of that change, either going earlier succession with more fire, later succession with less fire, or up and down if it's depending on how the hydrology changes out there. And so that's what we wanted to try. It's doesn't guarantee anything, but it gives you a sense as to what is likely to happen if you do something or don't do something, or somebody that's doing something that affects your property can have these kinds of effects. So that was the main goal of trying to do this. And this assumes organic soil accumulation over very long periods of time. So what that is. And this is sort of another thing that's tied to the cypress here, and this is Central Marsh Transept again. This is over on the far side of the Horseshoe, and this is the pine. And basically, this is that shell bed I was telling you about. And if you look at the water table during the wet season, it's fairly flat. But as you go down into the dry season, the water table's dropping. And I mentioned this is it seems to be a fairly continuous shell bed out here. And what it looks like is the water is leaving here faster than it can come down to it. The sands are fairly tight around there, even through the organics. You're seeing this drawdown as a result of this shell bed here. And one of the things I thought interesting, this occurs right along the edge of the cypress. And so that may be a major factor as to why the edge of the cypress is where it is. Because this area dries out more because of water being pulled out by the shell bed. And so this is where you get an area where fire can be fairly frequent. And it gets less frequent as you go that way. And it's pretty much always frequent just because it's upland, fairly dry environment. So, and there's all kinds of stuff. We did grazing studies about the transpiration, just all kinds of studies. So I figured this would make a nice package for this meeting.
We're running short. Let's take 1 or 2 minutes, just because it was a long talk. We'll make it up at a break. I'll leave the lights down.
I was got a question. The model you showed of successional vectors following severe fire.
Yeah.
Have you thought about how hurricanes may switch any of that around, or do you think that what's really driving those patterns are going to be fire and recovery?
Well, hurricane, we can look at another example of that. Another example of that would be Fakahatchee.
Yeah.
And it isn't a hurricane that put all that wood on the ground, it was the logging. You put a lot of wood on the ground, you can have a lot more fuel, you can have a lot more serious fires. And so places where the fires occurred are willows now. Places where the fires didn't occur tend to be more hard, sort of the original community with smaller cypress.
Yes. Hadn't thought about that synergy. Put wood in the ground, light it on fire, gets more severe. That's an interesting way.
Mark, are you doing, is there any more current research that might lend some insight on how maybe these patterns are changing more recently in this area?
Actually, I did talk yesterday. So the impacts of ultra-hydrology on ecosystem in Southwest Florida.
I thought I maybe heard you say that before, but I remember there was an issue about tomato farms pumping down.
About what?
Tomato farms pumping down.
For you, I came up there and this came up.
Not just farms, but